Good morning, my dear all students. Today our topic of study is generator protection. As I am showing you in the slide, first slide of our, that is generator protection. Nowadays, the generator size are increasing from 30 megawatt up to 500 megawatt, with the result that loss of even single generator may cause overloading in the associated other generator, which are responsible for creating an infinite bus bar. As a result, the protection applied to the generator will reduce the outage period to a minimum by rapid discriminative clearance of fault. Now, unlike the other apparatus, opening a breaker to isolate the faulty generator is not sufficient enough to prevent the further damages. So, generator is a very delicate instrument and we have to think of it how we can protect it against different types of fault. Now, next is introduction part. Now, it's a very imperative to install some protective system to protect against the expensive component of the like generator, transformer, transmission line, etc. Now, all the modern generator unit are invariably transformer connected owing to internal connection. That means when we are just wishing to establish a generating station, in that case we are going to install n number of generator. The number may varies from 1 to up to 7, 8, 10, and one single generator is not enough capable to compensate that huge amount of load. So instead of using a single generator, we are having a choice for n number of generator which are operating parallelly to compensate that load. And in that case, if the generating station are having n number of generator, generally at a time we doesn't recommend to run more than n-1 or n-2 generator at a single time of operation. Now, next, generator fault and their protection techniques. So before studying the generator protection, you should know how many types of fault may occur in case of generator. So let us first of all discuss about how many types of fault and what types of fault and what are the origin of the fault of different types of generator fault, and in that case we can get some protective devices to protect the generator from different types of fault. Now, first of all, we will discuss about the stator fault. The stator fault are basically classified into three categories: fetch to earth fault, fetch to fetch fault, and inter-turn fault. So, first of all, most of the fault occur in stator winding and their connections, and the majority of these fault are earth fault. Earth fault means the fault occurs from the different three phases direct to the connecting earth turns. Fetch fault and internal turn faults are less common. These usually develop into a earth fault. The effect of the earth fault in the stator are two types basically. First of all, it is arcing to the core which welds lamination together, causing eddy current loss, and different types of hot spot developed in the winding area, because as well as when the higher current will be flowing to the circuit, there will be huge I square R loss and the winding may not be capable of withstanding of that heavy heat loss. So it may be melted, it may be shorted. There are so many options. Repairs to that condition involve the considerable expenditure of time, and definitely money will be wasted and the system will be exhausted for a long of time. We have to go for a blackout. These are the current ways of the effect of the different types of fault. And secondly, severe heating in the conductor, because whenever we are going to manufacture a conductor, that will be having some specific rating, that how much time it can withstand against the rated value higher than the rated value of the current, which will be creating excessive I square R loss, and that will damage them, their insulation, and there will be possible of higher fire risk. So which should be considered in our mind. And second, not the least, that is rotor winding fault. Rotor winding fault. So how many types of rotor winding fault are there? Fault in the rotor circuit may be either earth fault or between the turn fault, which result from severe mechanical and thermal stresses acting on the winding insulation. Modern practice is to operate a generator with its field winding isolated from the earth, and therefore a single fault between the field winding and rotor body due to its insulation breakdown can be tolerated. It's very important to know the existence of such fault so that the generator can be taken out of the service and the system can be isolated from the faulty part up to the healthy part. So in that case, the rotor fault, if identified, it should be treated as early as possible. Then abnormal running condition or operating condition. The third point, abnormal running condition or operating condition. So the abnormal running condition are likely to be in case of generator. There are few types like loss of excitation, unbalanced loading, overloading, failure of prime mover, overspeeding, and over voltage. The field failure may occur due to a faulty circuit breaker or failure of the exciter. When the generator loses its field excitation, it speed up to the slightly and act as an induction generator. Supposed to be when the generator loses excitation, in that case it will fit the source and it will be acting like a induction generator, not like a synchronous generator, because the synchronization in between the stator and rotor is, or rather to say the coupling between the stator and rotor is already been broken. Now a fault in the voltage will occur owing to the loss of the excitation, which may result a loss of the synchronism inherently, and there will be a possibility of overheating in the rotor. Secondly, the unbalance may occur due to the single phase fault, unbalanced loading. That means in that case, if the different types of load are connected in case of alternator, and if those loads are not balanced practically, in that case there will be unbalancing created. Open circuit due to the broken line or due to the failure of one pole of the circuit breaker to close, although short circuit will normally be cleared by circuit protection. However, uncleared fault and unbalanced loading arising from one of the foregoing. Occasionally, this unbalanced current condition will be maintained by the generator. Now the next point will be the failure of the prime mover. Now, if the prime mover failed, in that case, it will cause a generator to run as a motor by taking power from the system. In that case, it is not a single generator system. The serious condition depends on the type of the drive used in this case and for the generator, and this may cause severe breakdown in the system. The system may go out to black. Then sudden loss of load. Supposedly the generator is connected across the load and the load is suddenly gone down. Because the load is at the consumer end, they may vary time to time, and if the load changes very suddenly, that cause machine to the overspeed, which will more likely to occur hydraulic generator, because the water flow cannot be stopped instantaneously. As a result, the energy and the mechanical that will coming from the hydraulic inertia that will may cause a damage to the generator system. And the last is over voltages. Over voltages is likely occur due to the overspeeding and due to the defective voltage regulator. Now, different process of protecting the generator. What are the different protection type we can provide to safely run the generator? Now, in the first case, that is stator protection. stator protection. This type of stator fault is likely to occur in between the earth fault current that is limited by the resistance and the neutral of the generator. Depending upon the resistance in the neutral circuit of the generator, the fault current may be limited to a value between 200 to 250 ampere, or in between maybe 4 ampere to 10 ampere. Resistor earthing employed to get the former value, whereas the distribution transformer earthing is employed for the later one. Now this method has it having an advantage. What is the advantage of this method? This method is ensuring minimum damage to the stator core, but it is not practicable. Okay. Now when the stator neutral is earthed to a resistor CT, in that case the protection system will be very much healthy. Now next is overcurrent protection. I will discuss with individual point what is stator protection, how it is given protection. That details I am just going to discuss with you in the very next slide. Then over voltage protection, over speed protection, rotor fault protection, and external fault backup protection. Now come to the very next slide. Very next slide is discussing the point which I have already discussed with you, that stator fault including the following, like phase to earth fault, phase to phase fault, and internal turn fault, which I am just discussing with you. Now the different protection scheme for the stator protection, like which protection scheme will be very much useful in case of protection of stator, like the differential protection. Differential protection is one of the very common protection scheme which already I have discussed with you earlier when we are discussing about the basic operating principles of relay. There was a protection relay which is known as differential protection. A very important, the differential name itself coming from that concept that whenever there is a difference of voltage and current in between, that relay will be operated, or relay tripping coil will be energized. And this type of protection scheme is also very much modified, and after a word we are using it like a March price protection scheme, and later on it is much more developed and which can be used as percentage bias differential relay protection scheme. I hope all of you can remember that why there is a percentage bias, as both the cities may not be having the same configuration. In that case we have to go for a restraining coil which is known as restraining coil or percentage bias differential protection scheme. Then the biased circulating current protection, balance earth fault protection, and stator overheating protection scheme. So one by one we will discuss about all the topics here. Then come to the next point, that is about the differential protection scheme. Like whatever I was discussing with you, the differential protection scheme, whenever there are two sets of identical CTs, they are mounted either on the stator phase winding or secondary of this current transformer are connected in stud. In that case, this type of protection scheme are very much useful in case of alternator protection. Now rather to say the generator protection, generally as a alternator, rather to say the synchronous generator we are using for generating stations as per our concern. Now at normal operating condition, the current at the two protection remains same. Normal operating condition, the restraining coil of the relay will be healthy, as I can show you in the next slide circuit. So the current, this is the generator which we want to protect, and these are the CT1, these are the CT2, and in between we have connected the relay tripping coil. And at the condition when both the current of both the CTs will be having the same current, no current is likely to pass through the relay coil and relay will not operate. But whenever there is a fault in any one of the winding of the generator, the current of the two CTs will not be equal. As a result, current will be flowing through one of the coil of the relay, and relay circuit will be energized, and it will instigate the trip circuit to discriminate the faulty part of the circuit from the healthy part of the circuit. Okay, So please go through up to this part. In the next slide, I will continue with the some new portions of the generator protection and some few knowledge I hope you can gather from it. Thank you all for your patience here.